In this video, we will start with the basic concept of momentum. We know that force is needed to change the velocity of an object. How much force is needed? That depends on the formula. F is equals to ma. Resultant force is equals to mass into acceleration. This is based upon Newton's second law of motion. Also, we have the equations of motion, the most prominent one being V is equals to U plus AT, and we know that equations of motion are only valid for constant acceleration. Now, let's rewrite this equation. F is equals to m times A, and let me make A the subject from here. So V minus U divided by T, that equals to A. So let's plug in this expression instead of A over here. So we have V minus U divided by T. Let's cross multiply. Let's take T to the other side and multiply it with F. So Ft is equals to M multiplying with V minus U. If I expand on the right hand side, this becomes mv minus mu. And on the left hand side, we have ft. Now, first of all, let's define momentum. Momentum is the product of mass of a particle and its velocity. The unit of mass is kilogram. The unit of velocity is meter per second. Therefore, the unit of momentum can be written as kilogram meter per second. But if we look on the left hand side of this equation, what do we have? We have force multiplying with time. This is known as impulse, and the unit of force is Newton. The unit of time is seconds. So this is an alternative unit for kilogram meter per second. And this is the more commonly used unit of momentum. So first of all, what does this equation say? We have Ft is equals to mv minus mu. This is the momentum based upon final velocity. Similarly, this is the momentum based upon initial velocity, and this is the difference in momentum, which equals the impulse. So now we are focusing on momentum. So momentum is a vector quantity. Why is momentum a vector quantity? Because momentum is mass into velocity. Mass is a scalar quantity, whereas velocity is a vector quantity. So the product of these two is momentum, which is a vector quantity. Now let's try out some basic questions related to momentum. Let's read this question. A particle of mass 4 kg has an initial velocity of 5 meter per second. Find the momentum of the particle. So let's start with the first part. It is simple. All we have to do is multiply 4 kilogram with 5. This comes out to be 20 Newton second. That is the initial momentum of the particle. It's a simple product of mass and velocity. In part B, it says the magnitude of the change in momentum. They are asking for the magnitude of the change in momentum if the velocity of the particle increases to 12 meter per second. Now let's calculate first 4 multiplying with 12, which is 48 Newton second. This is the value of final momentum of this particle. What is the difference? The difference is the final momentum minus the initial momentum. The final momentum is more, and that is 48. Initial momentum is 20. The difference is 28. The magnitude is still 28, and that's the answer for this particular part. Now let's change the scenario. Let's say in this question, the initial velocity was 10 meter per second and the final velocity was 2 meter per second. The mass is 4 kilogram. That means the initial momentum is more than the final momentum. That's 4 into 10, which is 40. The final momentum is 4 into 2, which is 8. The difference is final minus initial, 8 minus 40, which is 32. But I'm putting in the modulus sign, the absolute value sign. So therefore, I'm taking the magnitude. I'm discarding the negative sign. That comes out to be 32 Newton second. Let's try out another question. The question says, a particle of mass 2.5 kg has an initial velocity of 3 meter per second. Find the magnitude of change in the momentum of the particle if the final speed of the particle is 5 meter per second with the direction of the motion unchanged. And then there is part B. The final speed of the particle is 5 meter per second with the direction of the motion reversed. So now what we do is that let's make up a table. Let me write the initial velocity and then the final velocity. And then first of all, I'm writing velocity over here and then the momentum. The mass is constant, that is 2.5 kg. So now the initial velocity is 3 meter per second. The final velocity in the first part is 5 meter per second. Since we are taking 3 to be positive, 5 is also positive because the direction is unchanged. Now let me take this 2.5 and multiply it with 3. So 2.5 into 3, that comes out to be 7.5 Newton second. And similarly, I'll multiply 2.5 with 5, that is 12.5, and this is also Newton second. That's the unit of momentum. Now what is the difference in the change of momentum? And we need the absolute value. So the difference is final, which is 12.5 minus initial, which is 7.5, which comes out to be 5.0 Newton second. So the magnitude of the change in momentum for part A is 5 Newton second. Now, what about part B? The final speed of the particle is 5 meter per second with the direction of the motion reversed. So let me draw this table once again. We have initial, we have final, we have the velocity, and we have the momentum. So now the mass of the particle is 2.5 kg and the initial velocity is 3 meter per second. And this time the final velocity is 5 meter per second, but the direction is reversed. So therefore we are giving it a negative sign. So let's take this 2.5, multiply it with 3, that becomes 7.5 Newton second. Let's take this 2.5 once again, multiply it with negative 5, that comes out to be negative 12.5 Newton second. Now let's talk about the change in momentum. So the change in momentum is the final momentum minus the initial momentum. That is negative 12.5 minus 7.5. This comes out to be negative 20 Newton second. But since we are interested in the magnitude, therefore we will discard the negative sign and this answer comes out to be 20 Newton second. So what have we learned in this particular video? We have learned the idea that force is required to change the velocity of an object. We took the equation F is equals to ma, which is derived from second law of motion. We took the equation of motion V is equals to u plus at. We made a the subject, and then we made a single equation without the a. So the equation is impulse, which is the product of force into time, is equals to change in momentum. Momentum is defined as the product of mass and velocity. Momentum is a vector quantity. The unit can be written as kilogram meter per second, but the commonly used unit is Newton second. And then we did some simple questions related to momentum.